Okay, hello there everybody and welcome to today's lesson, section 10.7. We're going to talk about intersecting chords and intersecting secants and tangents and the length of certain segments that are created and how those segments relate to each other. Now we did intersecting chords and secants and tangents in 10.6, but those focused on the angles that were created. Now we're going to talk about the lengths of certain segments and parts and whatnot. All right, so two main rules we're going to talk about and then do some examples to apply those rules. All right, the first one up here. One quick thing. Remember that a secant means that it intersects a circle twice. So a secant is a chord. A secant and chord are pretty much the same thing. All right, so let's look at the first rule. And this rule involves two chords that intersect inside the circle. Two chords or secants. But we're mainly looking at what is inside the circle, not outside in this first rule. So the illustration or picture is going to look similar to this, something like this, where you have one chord and two chords. So first chord, second chord. Now, when you have two chords that intersect, you have four pieces that are formed. And we've labeled those four pieces here. Piece X, piece Y, piece M, and piece N. Now, here's the relationship between those four pieces. The product of these two parts on this chord is equal to the product of these two parts on this chord. Okay? So M times N is equal to X times Y. And that is an equation you can set up when you have a diagram similar to this and you solve this equation to find the length of whatever you need. Now keep in mind, like over here, I put a note of this. One of these chords or secants could be the radius or diameter. So it could go through the center like such. That's fine. You still have two pieces here, and you still have two pieces here. Okay? So if it goes to the center, no big deal. You just still use this rule like you normally would. All right, so let's look at the second rule. This one involves two secants that intersect outside the circle. So now we're looking at pieces, like in the first rule up there, but these secants are going to intersect on the outside. All right, so it's a diagram, usually that looks something like this, where you have a secant and a secant here, and they intersect on the outside. You still have four pieces that are formed. Two pieces here, two pieces here. Now this also works if you have one secant and one tangent, like the second figure, okay? You just really only have three pieces here, but we'll talk about that in a second. Okay, here's the rule for a figure that looks like this. It's not both of these multiplied equals both of these multiplied. It's not like the first rule. It's a little bit different. Here, the rule is the outside piece times the entire thing is equal to the outside piece times the entire thing. Okay, so again, outside part times the entire secant is equal to outside part times the whole secant. So like in this case, X, the outside part, times X plus Y, whatever the total is equal to outside part M times the entire thing M plus N. Now, if you just remember outside times whole equals outside times whole, then you can set up your equation and solve it. So outside part times whole thing equals outside part times whole thing. Okay, and again, like we mentioned here, this works for one secant and one tangent. You still apply this. Watch. Outside, which is m, times whole thing, which is again m. So it's m times m, or m squared, because the outside and whole are the same thing, is equal to outside x times whole thing x plus y. All right, so there are our two rules, and let's go ahead and use them to do some problems on the backside. All right, so let's look at number one. We're going to solve for x on all of these. Number one, we do piece times piece. So 12 times x, or 12x, is equal to 16 times 10. So 12x equals 160. We simply solve this, divide both sides by 12, and that will give us x. Let me grab my calculator real quick. We come out with 13.3. All right, so get number two. Number two, again, we're going to apply the first rule because we have two secants intersecting inside the circle. Let me look real quick. And that is repeating. You can round it, or you can just put the repeating for number one. All right, number two. Now we have some expressions here, but you still have to set up your equation. So we're going to do piece times piece, x times x minus 10 is equal to x plus 8 times x minus 14. All right, now you can distribute here to get x squared minus 10x. And you're going to have to FOIL over here. When you do first outer inner last, you're going to get x squared minus 6x minus 112. Now this might look like you have a complicated quadratic equation, but the x squareds are going to cancel because you subtract x squared from each side. So you have negative 10x is equal to negative 6x minus 112. And now you simply solve for x. Add 6x to get negative 4x. And if you divide both sides by negative 4 to solve for x, you get positive 28. All right, so that's number two. Numbers 1 and 2 right there, which apply the first rule from the front side. All right, let's try a little bit with the second rule. All right, so on number 3, we see we have two secants intersecting on the outside of the circle. So second rule here. Remember, outside times whole equals outside times whole. So that's how we set up our equation. So here we go. Outside 7 times whole thing 16 equals outside 8 times whole thing x plus 8. All right, we multiply here to get 112. Distribute here, 8x plus 64. And now we have a simple linear equation to solve, a couple inverse operations. Subtract 64 from 112, and that gives us 48 divide by 8, and we get x equal to 6. All right, let's look at number 4. All right, on number 4, we have a secant and a tangent intersecting, but it's still the second rule. So let's set up our equation. Outside times whole, so x times x plus 20 is equal to 32 times 32, outside times whole, because it's the same thing. All right, we distribute here to get x squared plus 20x. Set that equal to 32 times 32, which is 1024. Now here we're going to be stuck with a quadratic equation. When you have one of these guys, you want to have it equal to 0. So subtract 1024. Oh, there should be a minus sign. Now, this is a pretty big number. And if you're going to think of factors of 1024, one positive, one negative, that add to give you 20, you might be here a while, possibly. And you know what? It might not even factor to whole numbers. So what I suggest is to use an online quadratic equation solver. You can probably find something online or get some kind of app. In a little bit, if we have time, we'll go ahead and search for one, and I'll show you how to use it. All right, so, well, actually, since I'm recording on my phone, it's going to be tough for me to do. So we'll come back to number 4 in a second. Just hang on tight right here. We'll move on. Now, I took off number 5. There's no number 5. Let's go ahead and look at number 6. Now, number 6 is going to be similar to number 14 on your homework. All right, so make a note of that. It gives you part of a circle. So this is part of a circle. It gives you this entire chord, and it tells you, it asks you for the diameter. Now, this is coming out of the center. So the center of the circle is somewhere over here. If you go ahead and finish up the whole circle, if we draw the entire diameter going through the center, just this piece is 25. And the question they want you to solve or answer is to get the diameter of the circle. Well, since this is going through the center and hitting at 90, it chops this in half, so each of these is 60. This piece is 25, and this piece of the chord, we're going to call X. All right, so now looking at this, this is rule number 1, 2 chords intersecting. So we're going to go ahead and solve this like we did in number 1 above. We're going to solve this for X. And then we can easily get the diameter of the entire circle by adding it to 25. Whatever X is we get, plus 25 is the entire diameter. And that's how you're going to do number 14 on your homework, similar to this one. All right, so here we go. Piece times piece, 60 times 60, which is 3,600. That equals piece times piece, 25 times X, or 25X. Divide both sides by 25, and X comes out to be 144. And that's not your answer. That 144 is just that piece. The entire diameter is 25 plus the 144. So add 25 and 169 would be your entire diameter. Okay? Now let's go ahead and look at some of the notes that I've given you, some hints on some of the homework problems. Right below here, number 20, just solve for each variable separately. Pretend like it's two problems in one. Apply the rule for one of the variables and solve. Apply the rule for the other variable and solve. Right next to here, number 18. It looks pretty complicated, but it's kind of just like another two problems in one. The first thing you do is start with the small circle. Apply the rule and set up your equation for the small circle. Solve for that missing segment. And then work your way in the second part to the big circle and apply the rule. Set your equation up a second time for the big circle. Okay? That's number 18 on your homework. So try that on 18. Treat the small circle like a separate problem. And then go to the big circle and do another separate second problem there. And that should help you on 18. Now, on number 22, it's kind of like a word type problem. They want you to draw a diagram and then solve it. So I'm going to go ahead and help you with the diagram. And then you'll see it looks like one of our examples and you should be okay. It talks about two people standing next to a tree. So here's the tree, kind of like a bird's eye view. We're going to draw a bird's eye view, number 22 on your homework. And then it says one person is standing right next to the tree. So here's the person next to the tree. One person is a little ways off the tree. So this represents two people. Now it tells you oh, I'm looking for my picture. It tells you that this person is a distance of 16 away. And this person, which is tangent to the tree, is a distance of 27 away. And it wants to know the diameter of the tree. So you're solving for this. So when you set up your equation, you'll notice it looks like number 4 we did. And you can make an equation and kind of solve it like with number 4. Now, back to number 4. If you guys get a problem or two in the homework where you have a quadratic equation and you're not sure if it's factorable, if you just want to solve it with a solver online, you can. If you search online, quadratic equation solver, the first link or two, if you click on it, it should bring you, and you should have a lot of links available. It should take you to some kind of math app or math website or URL where you can plug in your A, B, and C values, and it will solve the equation for you, tell you what X is. Remember, A is the coefficient on X squared, B is the coefficient on X, and C is your constant or regular number. So if we look at number 4, A would be 1, B would be positive 20, and C would be negative 1024. So if you enter 1 for A, 20 for B, and negative 1024 for C, that will give you, usually it gives you 2 answers. Because quadratic equations, most of them have 2 solutions. And you would want probably the positive solution. It'll probably give you one positive, one negative. It would here, since C is negative. So you would want the positive solution for X. So if you get an X squared quadratic type equation, like for number 4 in a homework problem or two. You won't get them a lot in your homework, but maybe a problem or two at the most. Go ahead and find a quadratic equation solver, and just use that. Make things simple, because we're mainly practicing the geometry behind everything, not the algebra. And if you have another way to solve the equation, that's fine. There are other ways to solve a quadratic equation if you remember them from algebra. You're welcome to, use your own method. All right, guys, that is it for 10.7. Have a great rest of your day. And thanks for watching. Take care. See you next time.